Welcome to the Exponent Laws review lesson. So I'm going to go over the exponent laws that you covered last year in grade 9. Um, it, um, Again, like when you're using FOIL and multiplying, polynomials and so forth, and you are kind of using exponent laws all the time. But I just want to make sure that just for some of the more complex exponent operations that you do remember all of the different laws that you learned, okay? All right, so how I'm going to go about with this lesson is I'm going to kind of do an investigation like you would have maybe tried in grade 9 and then go through and kind of define the exponent law and then use it on some examples and so forth, okay? So there's a few different laws. There's one on multiplying. So again, feel free to like kind of, I don't know, skip through this video if you're like, I know how to do multiply, I'm good there. Then there's a dividing. What do you do when you have to divide exponents? And then some of the other ones were, it's no worries about like memorizing the name of the law, but there's one called power of a power. So there's two exponents up in the air. Okay. So what do you do when you have that scenario? A power of a product. So if you have a product and one power out here, what are you allowed to do? And the last one is a power of a quotient. So if numbers are being divided and there's an exponent out here, what's something that you're allowed to do here? Okay, so we're going to go through those. Just feel free to skip through the video and kind of cover the stuff that you maybe need a bit more practice with and so forth, okay? All right, but if you feel pretty confident with all of these laws, then you can skip right to the day 1 lesson that I've also posted, okay? Okay, so we're going to start off with just some basic review here of how exponents work. I find that sometimes you guys see this question like 2 to the 3 and you make a mistake and think, oh, that's 2 times 3 is 6, okay? So I need you guys to stop doing that, and so to help you, maybe if you do keep making that mistake, is to remind you, okay, so the bottom number here, the big number here, is the base, and then the little number up in the air is the exponent, okay? So even if it's a letter, the x here is the base, and the number here is the exponent. Okay, so whenever you have 2 to the 3 like that, you're writing the base that many times, however many times the exponent says. So the 2 has to be written over and over again, but you write it 3 times like that. So 2 to the 3 is not 6, it's 2 times 2 times 2, which makes it 8, like that. Okay, so just keep that in mind as you go through. Even if you have a negative, so see if there's a bracket around here, you can think of the exponent for owning the negative 3. So you have to take the negative 3 and write it 4 times like that. Okay, and then so negative times negative times. So you see how you have a even number of negatives, so you know the answer is going to be a positive number. And then you're going to go 3 times 3 times 3 times 3 is 81. Like that, positive 81. Okay, so same idea here, even with the letters, okay? So even though you have, you don't know what the base is and you won't be able to actually calculate a value out, just keep in mind that this is what you should be doing with the letters, okay? It's the x times x times x like that. All right, and then if it's a y, and again, if you want, you can write dots, okay, to say multiply, because I know a dot is a little easier than writing a bunch of brackets. So, all right, so keep that in mind as we go through. So we're going to go through and pretend, like I'm going to set this up so that we're going to pretend that you don't know what multiplying exponent law is. So we're just going to investigate it and then make a conclusion here. Okay, so for this first one here, I'm going to just go through and use BEDMAS. So that means I'm going to, take care of the exponents first. So I'm going to take care of the 3 to the 5. And then I'm going to use, or I'm going to calculate the 3 to the 3 next, okay? So if I calculate 3 to the 5, so that's 3 times 3 times, 5 times, right? So that'll become 243. Okay, so 243, that one. All right, and then the other one, 3 to the 3 is 27. Okay, and then now let's take the product, multiply those together, and you'll end up with an answer of 6,561. Okay, so that's just using BEDMAS, just kind of going through, okay, I got to do the exponents first before I actually multiply the values together. Okay, so if we're using exponent laws, this is how you're going to develop this method here. Okay, so so what we're going to do here is what we did up here. We're just going to write all the terms out. So for 3 to the 5, I'm going to write it out. Write the 3 5 times, like that. Okay. And then for the second one, 3 to the 3, I'm going to write it out 3 times like that. Okay, so if I do that, I'm going to have how many 3's there? Okay, so if you count them up, you will have 3 to the 8 like that. Okay, all right, so so from there, you're supposed to make the connection here that, okay, well, you had 3 to the 5 and 3 to the 3, right? So if you wrote them all out, you end up with 3 to the 8. So even if we try this one down here, okay, so if we wrote out 2 5 times, and then we write out the next one 8 times, oops, assume there's dots in between, okay? I'll put them in a sec. All right, so there's a dot, dot. Okay, and then there's still one more, the 2. Okay, all right, so how many 2's did I just write? Okay, so if you're counting them up, okay, hopefully you see that there's 15 of them. Okay, so with exponent laws, hopefully you're seeing that, oh, if I just add the exponents, I'll get the simplified exponent, and then all I have to do is calculate 3 to the 8 on my calculator, and I'll get 6,561, all right? And then there's 2 to the 15, I'll get 32,768. Okay, so again, this is using exponent laws. So once you can learn and memorize the exponent law here, that's all you're doing. You're adding the exponents and then you're simplifying the answer. So it's a little bit less work than what you have to do here, where you're calculating it, calculating again, and then doing a third calculation. So if you could just simplify it to here and then calculate to your answer, it's one less step. Okay, all right, so that's where I would like you to get to. So I'll just kind of go through the rest of this investigation here and show you how to calculate these using BEDMAS. So if we're back to doing B now using BEDMAS, so again, you just take your calculator. So here's a calculator. Again, the exponent button on this calculator is this roof button, but keep in mind that you can have, buttons like that. Okay, I think sometimes it's the other way. Okay, but yeah, like the roof button is a popular one. I think if you're using your cell phone has one of these. Okay, so you can use those to calculate it quickly. So right now, I'm going to do 2 to the 5 first. Okay, so on your calculator, you're just going to go to whatever your exponent button is, 5, and then hit enter, and you get 32. So you get 32 here. Okay. All right, so now I'm going to multiply 2 to the 8 next. Okay, so you're going to go on here, 2 to the exponent 8. Okay, you get 256. All right, and then the last one you should be able to do in your head, but okay, if not, but if you just want to practice on your calculator, 2 to the 2 equals 4. Okay, so remember, you're not going 2 times 5, 2 times 8. It's the exponent. Okay, so that means it's 5 times, or sorry, 2 times 2 times 2, like it's multiple 2's. Okay, be multiplied together. All right, so then now you're just calculating those 3 together. And again, with brackets and so forth, you could just enter them all into the calculator as well. And you should be getting this answer here. Okay, which is what we got on the other side. So the whole point I'm trying to show you here is, yes, you could go through and use BEDMAS, but if you can learn the exponent law tricks, it just kind of makes your work a little bit more efficient, and then you aren't crunching out as many numbers, okay? All right, so again here, we'll do this one on our calculator. So clear, delete, okay, yes. All right, so we have a -3, so bracket, negative sign, 3, okay? All right? That's important because when you go into take the exponent, it needs to know that it's controlling the -3, and you're writing it 3 times, or the exponent 3, so you get a -27, like that. Okay, so again, just showing you how to use it on your calculator, especially, you should be able to do these in your head, but if, when we get to some bigger numbers, you know what to do with your calculator, okay? All right, so that's using our calculator. So that was nice and easy, maybe like, actually, hold on. That should be nice and quick. But here, again, if you are just quickly simplifying it, okay, that's what you need to do. I guess over here, what you would have done on your calculator is you would have gone, -3 times -3, so it's annoying, right? Times -3, like that. Okay, enter, makes -27. So that's what you would have to do on the BEDMAS side, but on the exponent law side, these all have an exponent 1, right? So what I'm doing is I'm adding all the exponents to 3, and then I'm just crunching in these numbers into the calculator, and I get to my answer, okay? All right, so again, yes, pick up these exponent laws so that you can do things more efficiently. So here's the general conclusion summary, I guess. So this only works if the base is the same. So see how they both have a 3 for the base, and they have different exponents, but that's okay. 2 for the base. So you have to have the same base, and then you're allowed to add the exponents, okay? And you only write the base once. So in this case here, this is what you're doing. You're just going 2 to the, and then you're adding the exponents. Okay, and then you get 2 to the 15. All right, here's another one. So you have, write the base once, they have the same base, so you're allowed to add the exponents, because again, they're being multiplied together, okay? The dot is multiply. So you're adding the exponents, and so forth. All right, so a couple more, and then we can move on to dividing. Okay, so you're always simplifying, so those are the instructions, simplify using exponent laws. Okay, so we want to get it down so there's only one base. Right, and then we get x to the 14 and x to the 15 for the other one. All right, so that is your review of multiplying powers, so just like what to do when you're multiplying values that have exponents. Okay, so again, this works if you have the same base. All right, so let's move on to dividing. So same idea with dividing. It's very similar. Okay, so again, I'm just going to go through and use BEDMAS here. So I'm going to go 3 to the 5. Okay, so I'll go 3 to the 5. Calculate that, I get 243. Okay, 3 to the 3 is 27. So when I take these and divide them out, my calculator, I will get 9. Okay, so I had to do 1, 2, 3 calculations, right? So 2 to the 8. Okay, that's 1 calculation for the top. 2 to the 2, calculate that at the bottom, and then divide it. That's the third calculation, you get 64. All right, here we don't know the base, so I guess essentially you can't just use BEDMAS here, so I guess I shouldn't even have this question here, but let's, so anyway, we'll look at how to simplify it with the exponent laws here. Okay, so you have these ones here. So if I write them all out, say we're pretending we don't know what this law is, we're just writing them all out. 5 of these there, and then we need 3 at the bottom. Okay, so when we do that, what happens is that, I can cancel out some at the top with 1 at the bottom, 1 at the top, another 1 at the bottom, another 1 at the top, another 1 at the bottom, and that leaves me with just 2 of these left, okay? So 3 squared, which is 9. Okay, so we'll keep going and then see if we can see some sort of connection here. All right, so this one here, if we have 8 of them, okay, that's 8, yep, and then 2 at the bottom. All right, so again, cancel out. Okay, 1 top, 1 bottom. Okay, and that leaves us with 1, 2, 3, 4, 5, 6. So 2 to the 6, and then we can calculate that out. And we get 64, okay, and then then here, so writing the x. This is why we don't write the multiplication symbol anymore, because if we had all these x's plus all the multiplication symbols, it would have been really messy. Okay, so I have 7 x's there, and I have 5 here. Right, so we're canceling them out, 1 for 1. Okay, so that leaves me with 2 left, x squared. Okay, so from there I want you to make that connection before you get to the answer. So whenever it's 3 over 5 divided by 3 over 3, you got 3 to 3 squared. Okay, if it was 2 to the 8 divided by 2 to the 2, you got 2 to the 6. Okay, and here we got 2 to the 2. So what's happening here? We're subtracting the exponents to get to this form and get to our answer. So again, once you figure out this law, you don't have to do all of these here. Okay, just showing you how the law was developed, I guess. Okay, so you should know, oh, I could just subtract the exponents. Okay, but yeah, if when in doubt, like if you end up forgetting, you can always write them out like this and then cancel them out and get to your answer as well. Okay, but for now, from here to here, that's what we should be getting to. Okay, so it should be really quick. So again, you get to this step and then you calculate once. Okay, here you had to calculate the 243, then the 27, then you had to divide them and get the 9, so it's a little bit more time. All right, so here is the summary. So again, you need to have the same base. Okay, and then you can subtract the exponent, and the x shouldn't be a 0 because you don't want a 0 at the bottom of a fraction. All right, so here we go. So if we're using the exponent law, if I'm dividing these, I know I can subtract the exponents. Get to there, I get to my answer. Okay, with this one here, I know I can't calculate an answer, but I know that I can still simplify it because I know I could write the base once and subtract the exponents and get to there. All right, and let's get some examples out of the way here. So since we're dividing, so always pay attention, is it divide or multiply? So since we're dividing, subtract the exponents. It's there. All right, and then I kept saying over and over again, you have to have the same base in order to kind of go through and use these laws, okay? So just pay attention to what letters you have here. So I'm just going to write out the work here. So only the x's can divide together. So that means the 4 and the 2 subtract. The y's will divide together. So that means the 7 and the 4 subtract. And the z's, the 5 and the 4 subtract. Okay? All right, clean it up. That becomes 2. That becomes 3. Z becomes 1, but we don't write the exponent 1. We just leave it like that. But we know the 1 is actually sitting there. Okay? All right, so now you've had a good review, hopefully, of dividing the powers out. Okay, so again, I'm doing these investigations to help you kind of remember these laws a bit better. All right, so the next two. Again, don't worry about remembering the name of the law or anything, but just kind of know what to do when you see questions like this, okay? So I'm not going to keep doing the investigations, but you can kind of do them out, write them out yourself if you want. Or you know what, if you want me to do a few, I could do a few here. But for now, like this is what you're doing when you have one base and then you have an exponent with that base, and then there's another exponent outside in brackets. Okay, what do you do in that case? Okay, so I'm gonna just do an investigative one here. And so what I'm gonna do here is, so again, BEDMAS will say, you know, take care of the brackets first. Okay, so you would deal with whatever's inside the brackets first. So there's 5 of those. Okay, but then it's saying, okay, so then there's an exponent on the outside. There's 3 of those. So basically you have to write what's in the brackets 3 more times. Okay, so there's 5 of them inside the brackets, but you have to write it now that the exponent's on the outside, 3 or more of those. Okay, so then we'll go through here. Okay, so there's the first set of 5. Here's the next set of 5, and there's the last set of 5. So, so that's what's happening there. So when we clean this all up, you're noticing, oh, it's 3 to the 15. Okay, so then when you go through, you will get a really big number here. Okay, 1, 4, 3, 4, 8, 907. Okay, there you go. All right, so that's what you get. If you wanted to use BEDMAS, you would go 3 to the 5 first. So if I write this again right here, you would take 3 to the 5 first, and you would get 243. But then that exponent 3 is still on the outside, so now you got to take a power to the power 3, and then you get to that number as well. Okay, so again, if you can pick up these exponent laws, you can do this a little more efficiently, so you don't have to calculate this and then do the second calculation to get to this answer. You should be able to go, oh, well, I have a 5 and 3, right, exponent here, so then it became 15, so what's happening here? Okay, so hopefully you can see that you need to take the product of the exponents. So when you have one base and two exponents up in the air, you take a product. You multiply the exponents together. Okay, and then you can get to your answer. All right, so I'm just going to do one more investigation here, and then hopefully you can see what you're supposed to do, and then you can use the exponent law to your advantage here. All right, so again, I'm going inside the brackets. I have to write 4 twice like that, but then the exponent on the 3 is saying, oh, well, you have to do that 3 times. So I need another set here, and then a third set of 4 like that. Okay, so when we clean this all up, that ends up with 6. Exponent 6. Okay, there's 6. There's 6 4s, so 4 to the 6. All right, and then when you evaluate that out, you end up with 4,096. All right, so again, what are we noticing about the exponents? We have a 2 and 3 in the air, so when we multiply them, we get a 6. All right, so now that you've seen this law, I want you to go through and use it on these next 2 examples here. So again, this one here, the exponent belongs to whatever, like whatever it's beside, okay? And if it has a bracket, it owns everything in the bracket. So this one here, this x here sitting outside, it doesn't have the exponent 2. So if there's no exponent there, it's like there's an exponent 1 there, okay? So if we're going to evaluate this, well, we just have x. But now we're going to have to take care of the y here. This exponent 2 is beside the y to the 17. So we're going to go through and we're going to multiply the exponents together, and we'll get y to the 34. Okay, so again, we don't need to write the brackets here. X just has the exponent 1, the y has the exponent 34. Okay, but 34 does not belong to the x, okay? It's just a 1 there. Again, it belongs to whatever letter it's right beside, like this. But if you wanted it to belong to the x, this is what you would see instead. Okay, you would see that, oh, the 34 is for both of them. Okay, but right now it's just on the y, so that's how we write it. So don't write it like that. All right, so that's cleaned up. Let's simplify this one. Okay, so again, so this 6 owns, okay, is the exponent for this first bracket. This 8 is the exponent for this second bracket. So just make sure I respect that and go through and clean this up. All right, so I want to simplify it so there aren't 2 exponents like that in the air. So I know that when I have one base and 2 exponents like that, I need to multiply the exponents. Okay, and this one here, b, multiply those exponents, you get to 24. All right, so that's the power of a power. So it's like, it's the law where there's one base and 2 exponents up in the air. So, we have an exponent outside of some brackets and so forth that you have to, you can clean up and by multiplying together. All right, so here's the next one, power of a power. So this one here, that's what I was showing you just now. So when you have a bracket around everything, that means that that exponent belongs to everyone inside. Okay, so here, if you wanted to do the investigative part, so you're seeing that you have 2x, and you have a couple of them like that. And then now you, when there's an exponent 3, that means that there's 3 sets of them. Okay, so you have 2x, x like that, and then we have another one, 2x, x. Okay, so it's saying that because it's the power of 3 here, so 2x squared, you have to write it that many times, and so in the end you end up writing it 2 times 2 times 2, okay, well, or 2 to the 3, and the x's, there's 6 of them. Okay, so that's how you would write it. So how did we, so what did you notice about, oh, And then I guess let's evaluate this number here because we know it. So that's 8. So what did we notice from here to here? Well, it's like this 3 went on to the 2, so it became 2 cubed to make 8. And then with the x's here, the exponents were multiplied together to make 6. Okay, so that's what you're doing here. All right, so think of it like, like that. The 3 belongs to everybody inside. So even if there is no exponent, there is one here, right? It's like it's multiplying to this one. 1 times 3 is 3. 2 times 3 is 6, like that. Okay. All right, let's do this one as well. So this 2 belongs to everybody inside of here. So I'm going to use the exponent law now. So again, this one has an exponent 1, that one 2, and that one 3. So I'm going to multiply this 2 to the 1 here. So that makes it 2. I'm going to multiply the m squared with the 2 here to make it 4. So here, why don't I actually write all the work out here? So it's like 1 times 2, okay, and then the m is 2 times 2. And then the y will be the 3 times 2. Okay, so that exponent 2 multiplied into the exponents that are already on the values in the bracket. All right, so let's clean this up. So that becomes 3 squared, that becomes m to the 4, that becomes y to the 6. And then again, I can clean up the 3 squared, make it 9. And the letters stay the same like that. Okay, so that's using power of a product. So if you already have a product inside the brackets here and there's an exponent outside, you can multiply that exponent into all of the exponents that are on the inside, okay? So, and again, if it doesn't have an exponent, like this 3 here, just if there is a 1 there, okay? All right, so that's power of a product. So the next one's similar, just that now inside the brackets you have a quotient, so numbers that are being divided. But the same thing applies. You can bring that exponent into everybody inside, okay? All right, so I'm not going to do the investigation maybe for this one because there's a lot of them to write out, but hopefully you would see that I would write out 15 of them, and then so 5 of these, and then I would write out 10 of those. 5 of these ones, 10 of those ones, you know, they're altogether there'd be 15 if we simplified the exponents. Okay, so this is more just the, so like we're just going like this, we're adding the exponents because they're being multiplied together. Okay, so 2 to the 3. So we can even think of just whatever's in the bracket right now as just being one number. And so if we're multiplying the same base together, we add the exponents. So we get to here, okay? But we can simplify this even more. So I want you to think of it as with this law here, okay, both of them, you know, have an exponent 1 inside. So you're allowed to multiply that exponent 15 into both of the values at the top and bottom of this fraction here. So it's like going 1 times 15 and 3 to the 1 times 15, like that. So you end up going 2 to the 15 divided by 3 to the 15, okay? And then you're going to divide those out. So 2 to the 15, end up with a large number here. Okay, and then you have 3 to the 15. Okay, you get to that number there, and then calculate the final answer out. So okay, and then you get this tiny number in scientific notation. So just 1, 2, 3. Okay, so you get that. So what we want to do instead here is we want to reduce this fraction if possible here. Okay, so it looks like this fraction might be reduced, so we can leave it like that, okay? All right, so yeah, so that's, this is the power of a quotient law. So basically, if there's a number on the outside, you should be able to multiply that exponent in to simplify it, okay? All right, so let's try the next one here. All right, so we have a 3 on the outside. It's like they both have an exponent 1, so I can write it like this. Okay, and again, some of you might be like, well, why can't I just take 7 over 8, put it in my calculator. So if you did that, 7 divided by 8, right? And then you go exponent 3, you're going to get a decimal answer, okay? And we don't want decimal answers in grade 10, so this is a way to kind of keep it as a fraction form, right? So if we multiply that exponent 3 into both of them, it becomes 7 to the 3 and 8 to the 3, and then we can write those out. So that becomes 343, and 8 to the 3 becomes 512, and I'm not sure if that will reduce. Nope. Okay, so that's reduced as well. So just leave it like that. Okay. All right. Here's the next one. So here we have a negative number here. Okay. So I want you to remember that whenever you have an even number of negatives, right? So if you have an even number of negatives, you end up with a positive answer. So in this case, 1. If you have an odd number of negatives being multiplied together, you always end up with a negative answer. Right, so in this case here, we know that when I take this 4 times, right, I'm going to end up with a positive answer. All right, so so from there, you could just write, it's the same as writing it like this, okay? If you don't like that, if that's weird, remember you can move this negative around, so you can move it to the top, okay, like that. And then and then when you go to distribute that 4 in, you have to think of it as like this is negative 3, and then that 4 goes on here. And then 5, the 4 goes on there. Okay, so just kind of respect that negative, make sure it's going to either the top or the bottom number. I always, as a rule of thumb, move it to the top. All right, so 3 to the 4, okay, negative 3 to the 4 is 81, and then 5 to the 4 is 625. Okay, and I believe that won't reduce. No, okay. All right, so that is the power of the quotient. So the main thing is you want to be able to simplify through by multiplying that exponent in and so forth, okay? All right, so that ends our review of what you should have picked up last year, and if it's a little bit, yeah, like you're having a hard time remembering, so just kind of review this, go over, try the examples again. I'm going to give you some questions today where you can practice this, but I just want to teach you the 2 new laws that called the zero exponent and the negative exponent. Some of you may have seen it, some of you may not have seen it. So those are considered to be the new things in grade 10. What I want you to do now is go to the video, the next video that's posted today on zero and negative exponents.